Okay, hello everyone. Welcome to the hybrid exam prep party. This is the second session. And if you would like to have access to the first session, okay, this I have written my email address here, okay, and you can just, send me an email. I will send you the recorded session for today's session. Okay, since we did until question number 3, okay, so now we will start working on question number 44. Okay, so what I do, I'll try to read the problem first, okay. So we have a 1000 kilogram automobile. What does it mean? This 1000 kilogram is mass, yes? 1000 kilogram. And enters a freeway on a ramp at the speed of 20 meter per second. So it means that the initial velocity is 20 meter per second. Good. And accelerate, accelerate. Okay, there will be acceleration, yes, up to 40 meter per second, yes. So it means that the velocity changing from 20 to final velocity is going to be 40 meter per second. Okay. How many second? In how many second? 10 second. How far does the automobile travel? How far does the automobile travel? Okay, it's telling that what is the D, yes? So this is a question which velocity is changing and we have acceleration. And then we have a accelerate and we can calculate the acceleration, yes? Because we have final velocity, initial velocity, and we have a time. Good. What is the acceleration here? This formula, yes? Change of velocity over time. What is the change of velocity? V final minus V initial, yes? Okay. Triangle means change. Delta. Okay, is representing the delta. So if I want to calculate the acceleration is going to be delta V over delta T. What is the delta V? V final minus V initial. What is the V final? 40 minus what is the V initial? 20 divided by how many seconds is going to be the time interval? Yes?
10 seconds.
10 seconds. Okay. Acceleration will be 40 minus 20 is going to be 20 divided by 10. It will be 2 meter per second squared. Good. So I have a acceleration. Did I need acceleration? Did the question ask me to calculate the acceleration? No. It can ask me to calculate the distance. Okay. I look at the formula sheet in the right. Okay. So where there is distance, acceleration, and time.
Can I ask one question?
Yes.
I just wanted a reminder. I know, like in this case, like D is distance, one half acceleration, time squared.
Yes.
What does G stand for?
G is for free fall.
Oh,
Okay. For instance, when you are dropping the object, yes, or when you are throwing in the air. Okay. Everything, every time that you are using, this formula, instead of A, you just plug G. Good? Okay. So distance, how we can calculate the distance is 1 over 2 acceleration T squared. Yes? Okay. So do I have acceleration? Yes. Do I have time? Yes. And I can calculate the distance traveled. Good. 1 over 2 acceleration is 2, yes. And time is Okay. So when you calculate this, what you will get?
I got 100.
100, yes?
Do you want us to put the numbers around with parentheses or? If so?
No, 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 no. I just try to separate them, you know. So do you think this is the right answer?
I think so. Wait. Okay.
This formula is for when initial velocity is 0, yes? But initial velocity here is not 0. Okay. So we need to rewrite this equation. We say d is equal v initial multiplied by t plus 1 over 2 at squared. Good?
Oh, okay.
Yes?
So the initial velocity in time plus that.
Yes. Initial velocity, you know?
Doesn't start at zero.
But there you go. Okay, this is very, important. Okay, so this formula is when the initial velocity is 0. Okay, let's say you stop. Okay, your car accelerate. Make sense? Okay.
I
And
couldn't figure out what I was doing wrong. I'm like, this is.
and now, okay, then 100 is not correct. Yes, okay. So I need to just say, yes, this part was okay, but I need to add this part as well. Okay. So again, it would be better to write in the formula sheet. Okay. So, but we haven't written that. Okay. But you should know that. Okay. So D is gonna be velocity 0 t plus 1 over 2 acceleration t squared. Good. What is the initial velocity? 20 multiplied by 10, yes, plus 1 over 2 to 10 power of 2, yes? 2 and 2 cancel each other. 10 power of 2, 100, yes? This is 100, and 2 times 10, 200, yes? It's going to be what? 300. Okay, okay.
I was like, I don't understand how they were getting.
No.
Okay, again,
I-
just make sure that when you are using formula, okay, you can add something in your note that, okay, this is for when, yeah, there is acceleration, okay, but when the initial velocity is 0. But when there is an initial velocity, you need to add this term to the equation, yes? V0t plus 1 over 2 at squared.
And if I could only use notes on this exam.
No, but I'm just telling you right now, okay? Keep it. Bruh, because I feel that we need to update this formula sheet, okay? So,
Can you tell them for
Right.
tomorrow?
yeah,
For tonight.
no, no, no.
We have no story about like choosing a wrong formula.
Yeah.
There's so many letters after this. So also,
Okay.
for these, I guess I was getting confused thinking that this V
Delta V.
for when, the very first one,
Yes.
that's always for when we're trying to find when it has another V.
Exactly.
Put that in there.
Yes.
Whatever.
Yes.
I was thinking it was just that part.
Yes.
And
That part helps us to find the acceleration, okay? Because acceleration definition is change of velocity over time. Are you looking for something? Excuse, are you looking for something?
Exam prep.
126? Oh, okay. So let me just.
I did. I did. He goes, here's pictures already sent. He doesn't like it, so he'll probably give us something different tonight. And I'm like, oh, give it to us now. And he's like, yeah, you can use that one for now. Like,
Who are you taking the class with?
Omar.
Okay.
I don't know. Yeah, it's a hybrid, so it's online and in person.
Oh,
So
okay.
we do all our labs in person and then our tests in person. It's just Tuesday nights, so.
I'm in an online class. Yeah, it's really hard to ask for questions.
It-
She doesn't really respond.
Sounds annoying.
Yeah, it's-
Retaking this class, because I tried taking the last semester, but I didn't do too well.
Yeah.
Take with the same professor again,
Yeah,
which is nice and everything, you know, but
who do you have?
Stanley,
Oh, okay.
so he's pretty cool.
Cause I attempted to take it with someone before
Yeah.
and she just changed everything all the time on us. So, like all the due dates, all of a sudden she's like, oh, it's actually due today. And I'm like, it was supposed to be Sunday. And she's like, well, I moved it up. I'm like, oh my God. So.
yeah.
And they work full time. So, I get the email. She's like, by 3 o'clock Friday. I'm like, I know work. So nice.
Yeah, one of my history professors right now has all of their assignments. It has to be turned in by noon.
You're like,
I'm
Okay.
like, and he wants it in a very specific format, like you can't turn the docs as a PDF,
Yeah.
you can only turn them in as like a certain format, it's weird.
Okay. More explanation about this question, or velocity is changing. When the velocity is changing, definitely there is acceleration. Okay, we have velocity's value, we have the time value. We can calculate the acceleration. When we calculate the acceleration, is asking to find the distance traveled, yes? Okay, we look at the formula sheet, okay, and you see that d equal 1/2 at squared. But there is a initial velocity, okay? So not only you need to add that part, okay? You need to include the initial velocity as well, okay? So
see though, the V0T,
yeah, V0T, yes, okay.
that's always what you put in
Yeah,
if there is an
exactly.
certain velocity.
Good.
Okay.
So 0 means initial?
Yeah, initial, okay. Sometimes they just use it I, sometimes they use it V0, okay? Same meaning, same thing, okay?
That's the initial, right?
Yes.
Fine, okay.
Yeah,
Sorry.
V initial or V0, okay?
Sorry, I wrote it down, I just want to make sure.
Question number 45. Okay, so 45. So what horizontally applied force will accelerate? What is asking? What horizontally force? Yes? Is asking me what is the force? Good. Accelerate. Okay, how much? 400 kilogram. What is the 400 kilogram? Mass. 400 kilogram. Yes? What is this value? Acceleration. Okay. Acceleration is 1 meter per second or meter per second squared. Good. Okay. Second squared. Meter per second is the unit of the velocity. Okay. Meter per second squared is the unit of the. So you see, while I'm reading, okay, so I'm getting some data. Force, mass, acceleration. I don't have the force, yes? I have mass and I have acceleration. Which formula I can use? There you go. F equal ma. Okay, let me change the color. F equal m time a. Okay. Can you hear me? Okay. Make sure if you want, you can come closer. Okay. Sometimes, hi. Can you hear me? Yeah? Good. So go ahead and just plug it. Okay. F is equal. What is the mass? 400. What is the acceleration? 1. Okay. It's going to be how much? Am I right? No, because I didn't read the entire problem. Okay, so I'm just trying to make your mistakes. It is more likely that you don't read the entire problem. Okay, please, please, please read the problem word by word. Because I stop here. I saw that I have everything. Mass acceleration, F is equal mass time acceleration, boom, 400. They put 400 here, and then you select it, but there you go, you are wrong. Where I stop here, yeah? Okay, let me just read the problem. Okay, there is more. Okay, you know, across a fact, there is acceleration 1 meter per second squared, but it's telling that a factory floor against a friction force. Friction force, half of its weight. It's very important. So I need to draw, yes? There is an applied force. Good. But there is a friction force. What is the friction force direction? Is always in the opposite direction of the motion. If you are pushing forward, the object move forward, yes? The friction force will be against it. Okay, so I'll just draw, this is my friction force, yeah, friction. It's telling that friction force, half of its weight. Half of weight, yes? This is weight. What is the weight formula? Look at here. Weight is somewhere. There you go. Mass time gravitational acceleration. mg divided by 2, yes? Weight. It's telling that the friction is half of weight. Okay. Tammy is there. Okay. So how can I calculate the weight? Weight is, weight is mass, yes. What is the mass? 400. What is the g? 10. Always 10. 10. Always 10. G is always 10. The magnitude of G for the exam, for homework, everything. It is 9.8, okay, but we round it to whole number, okay? It's 10. 400 times 10 divided by 2. What is the friction force? 2000 Newton, yes? Okay. I was not supposed to use this formula. Okay, I will erase it. Now I'm supposed to use this formula. Net force, yes, net force. So you can rewrite this. Okay, this is a F net, yes, equal mass time acceleration, yes? So what is the F net? Resultant of the forces, yes? How many forces we have? How many horizontal forces we have? 2. Which one is positive? Which one is negative? The capital force, applied force, is positive, yes? Friction force is negative. F net means adding forces, yes, with their, yes, sign. Good? Signs. Good? So F net. How many forces I have? I have 2 forces, yes? 2 forces. What is the first one? Applied force. Okay, applied force. Positive or negative? Positive or negative? Positive F. Plus, adding, you see, adding, yes? I put plus. What is the other force? Friction force. What is the sign? Negative friction force, yes? Equal to mass time, yes? See, mass time acceleration. Good. So, what is the F? I don't know. I just write it. Good. What is the friction force? I already calculated. Yes, it is 2000 Newton, but positive negative is going to be negative. Yes, equal. What is the mass? 400 multiplied by 1. Yes, 400 times 1 is going to be 400. Good. How can I solve the F?
Add 2000.
Add both sides by F is going to be how much? Okay. Question. Does make sense or I need to explain one more time?
Makes sense to me. It's just like, it's a 3-step process.
I know. I know. This is one of the question. Okay. It does have more steps. Okay. That's why you need to understand the problem conceptually. Okay. You just say that net force, net force cause a system move or accelerate. Sometimes there is just one force exerting on a system. Yes, applied force. Sometimes there are more than one force.
There's more than one, we always need to do the net
Net force.
versus just trying to find force and do it that way.
Perfect. That's it. Okay. Yeah. Okay. Let me just, give you one more example. Okay. Let me just, give you one example. Okay. So let's say there is a car. Yes. The car, mass is 100 kilogram. Good. And this car is accelerating 2 meters per second square to the right. Yes. But there is a force pushing this car. Okay, let's say it is, 400 Newton. Yes. But there is a force, friction, which is opposing from movement. Good. And I ask you, okay, these two forces combined together, yes, cause the car to accelerate with 2 meters per second square. Good. And the question is find the friction. Okay. How can I find? I say F net is equal to what? Mass of the car time acceleration of the car. Good. What is the F net? How many forces in the direction of the motion are exerted? First, identify forces. How many forces do you see? 2. One to the right, applied force, positive applied force, plus net means adding, yes? What is the other one? Friction. Okay, the friction between the tire and the ground. Good. But this force is in the opposite direction. I should put negative friction force. Good. Equal to mass time acceleration. Make sense? What is the force? 400. Positive, negative is negative. Yes? Positive, negative means negative. Okay. So it's going to be friction. Good. Equal. What is the mass? 100. What is the acceleration? 2. Okay. Solve for F. This is going to be 400 minus friction force equal 10 times 100 times 2, 200. How can I solve this? Minus 200, yes. Minus 200 plus F plus F. Good. These two cancel. What is left? F. These two cancel. What is left? Last problem is giving us the friction force. This is telling that the friction is half of the weight. Okay, calculate the weight. Weight is mass times gravitational acceleration. Yes? Calculate the weight divided by 2 is going to be your friction. Done. You calculate the friction. But it's telling what is the applied force. Yes? Sometimes applied force is given and you are supposed to find the friction. Because these two forces together cause the system accelerate. Okay? Not just one force. Combination of forces. Make sense? Okay. Let's move on to the next one. Okay, 46. Read the problem. If more horizontal force is applied to a sliding object than is needed to maintain a constant velocity, so it's telling that the object accelerate opposite the direction of the applied force, the object accelerate in the direction of the applied force, the friction force increase, 2 of the above, none of the above. More horizontal force is applied to a sliding object. Okay, what happened? The object will accelerate less or accelerate in the opposite direction, accelerate more in the direction, yes, of the applied force. Good. The friction force increase, 2 of the above and none of them. What is the definition of the net force? Mass time acceleration. Net force, inside the net force there is a applied force, yes? If you increase the applied force, what happened to the acceleration? Increase, yes? Because we are not changing the mass. The mass is going to be the same thing. Good. It's telling that horizontal applied force sliding increase, yes? What happened to the acceleration? If it's needed to maintain a constant velocity, okay, so if you want to keep the constant velocity, it means that you need to, let me just write it. F net is equal mass time acceleration, yes? If you want to, so what happened? If you want this constant velocity, it means that acceleration should be 0, yes? If you are exerting more applied force, okay, so what happened? If you want to keep the, the velocity constants, okay, in what direction, okay, you need to accelerate or have force?
To have it constant, you'd have to have it on the other.
Yes, to maintain a constant velocity.
Even you have to go.
Opposite direction, yes, okay. But it's telling that if more horizontal force is applied to a sliding object than is needed to maintain a constant velocity, it means that, that force was okay to keep the velocity constant. Now you are increasing the force, the velocity will not stay constant, yes? The velocity will not stay constant. Acceleration is not going to be 0. What happened? The object accelerate in the direction of the applied. Make sense? It's telling that the net force was 0, but you are keep adding more applied force, yes? It will not stay constant, yes? It will accelerate more. In what direction? In the direction of the applied force, yes? So the answer is 47. When a falling object has reached to its terminal velocity, it accelerates is, there you go, 0, yes? Terminal velocity, it means that, force of gravity and the drag force become equal to each other. They cancel each other, so the net force is 0. When the net force is 0, it means that the acceleration is 0. Okay, so right answer is 40, 0. What is the 48? A large and a small person wish to parachute to equal terminal velocities. The larger person will have to pull upward on the supporting strands to decrease the downward net force. Jump first from the plane. Jump lightly. Okay, get a larger parachute. Why?
Surface area.
Perfect. Okay. Increasing the surface area. Okay. Increase the drag force. Okay. If you want to still move with the, terminal velocity. Okay. So it means that you need to change the parachute. Yes. Okay. So to need to have a larger parachute if you are increasing the weight, because the air drag force would be equal and opposite direction of the force of gravity. If you are changing this, you should need to change this as well. How you can increase the drag force? By making the surface area larger. Yes? Make sense? 49. A coconut and a feather fall from a tree through the air to the ground below. The amount of air resistant force is greater than feather, greater than the coconut, the same on each.
What is the air resistant force?
So, wait,
Okay, let's say we have an object, and this object can be anything. Okay, let's say M. What is the force of gravity? mg, weight. This is a drag force, yes? Now we have two different mass, yes? One is what was that? Feather, okay. And what is one is the coconut? Drag force, okay. Make sense? Because again, this M can be anything. Feather can be, ball, can be, coconut, okay, can be anything. So if you want to keep this, mg equal to the drag force, yes, good. So definitely, d is gonna be equal to the weight of the falling object. The feather, what is the weight of the feather? Mass is very small. Time, g is gonna be a small drag force, yes? But the coconut, okay, has bigger mass, okay, bigger weight. It means that it's need bigger drag force, okay, to keep it in terminal velocity. So which one is the right answer? Greater on coconut, yes? 50. Okay. A skydiver steps from a helicopter and fall for a few seconds until reach his terminal velocity. Thereafter, until he opens his parachute, his acceleration, you know what happened? You jump, okay, You don't open the parachute, okay. You go, well, while you are moving, okay, the air drag force increase because air drag force is directly related to the velocity. As your velocity increase, yes, it's speeding up. The drag force increase. At one point, drag force and your weight become equal. Okay, and couple of seconds later, okay, you were moving with the constant velocity, okay, terminal velocity, and then you open the parachute. What happened? Air drag force suddenly become really big, yes? Bigger than your weight. Okay, based on this, okay, which one is the right answer?
Wait, so the drag force, it decreases when you're falling, but then increases when like wouldn't it decrease if, wouldn't it decrease if you open a parachute? Because you're moving slower?
You know, let me just explain one more time. Okay. So you jump, what happened? You fall. Okay, free fall. Okay. There is an air drag force, yes? At the beginning, very first, when I jump, the only force that is exerted on me is the force of gravity. But as I move through the air, yes, air drag force, okay, and these air drag force increase until become equal to the weight of the weight, yes. At that point, what would happen? These two cancel each other, yes. The acceleration become zero because the net force is zero. You are moving with your terminal velocity, and then suddenly you open the parachute. Okay, what was the acceleration? Okay, before opening your parachute.
Acceleration, zero, right? Because you reach terminal velocity.
Good. But when you open, drag force again become bigger than your weight. Okay, you just move up. Okay, a little go up. Okay, and then come back. Okay, so you have seen these parachute people. So what happened then? Until he opens his parachute, okay, the acceleration is zero. Okay.
They're saying that the terminal velocity.
Yes. Yeah. Until he opens. Okay. Again, read the code. Okay. Because when you don't read
He was falling before terminal velocity.
when you don't read the until, okay, what does it mean? It means that yeah, that the drag force, okay, is gonna be bigger than okay. When you open, okay.
When it opens, does that mean it decreases?
Yes. No, the drag force increase, okay. No, the drag force is gonna be bigger than your weight.
Okay.
Okay, that's why you just move a little up. Okay, you open, you just move a little up. Okay, good. And it's because of that, the drag force suddenly become bigger. Okay, what happened? The drag force, you're just increasing the surface area because your surface area was your body. Okay, let's say this is your body. Okay. What is the surface area? Very small. When you open, okay, let's say this is the open what surface area has become much bigger than the surface area. Okay, the drag force increase, okay, 10 times bigger than. Okay, good. It's not going to be exactly equal to the weight. Okay, it's going to be a little bigger. That's why you just move a little up. Okay, and then again the force of gravity, you know
Drag force is how much they take up.
how I don't know how much depend on the situation. Okay, so but suddenly the drag force increase. Okay, the drag force that the system was experiencing was now it is different than the drag force that you were experiencing when the parachute was not open. Makes sense? But in this question, it's telling that until it means that what was the acceleration when you had the terminal velocity. Zero. Make sense? Okay, 51. A pair of tennis balls fall through the air from a tall building. One of them is filled with lead pellets. The ball to reach the ground first is the lead filled ball, regular ball, same for both. Why same? It's talking about the drag force here. It's not talking about the same the drag force. When it's not talking about the drag force, okay, assume that all happening in the vacuum. No drag force, yes? Okay. Now you drop feather or coin or whatever. Okay. Two. Which one reaches the ground first? Heavier one?
In this case, it'd be the lead filled ball.
Make it feel like
Citizen in a vacuum.
Hmm?
In a vacuum, right?
Yeah, in a vacuum. Okay. So it means that there is no air resistance. How many saying we have? Oh, which one you select? No, that's okay. Okay, so which one do you select?
First I was going with lead, but your reaction makes me think that that's wrong.
Okay.
So. Air resistance, then I would say it's the same.
So air.
Air is a vacuum? No. Do we have air drag force? Yes. Okay, it doesn't say anything. That's I'm just trying to just make you a little confused here. Okay, so good. Physics 120. Why? Oh, okay. Again, air. It doesn't say anywhere. Okay, you were right. Okay, if there was no air here. Sometime in the question, it says there is a drag force
Neglecting.
or neglecting air resistance. Okay, so there is a air, but you can neglect the air resistance. But here is telling that there is a air, but it's not telling neglecting the air resistance. Okay, so you know the concept. Okay, but you misinterpret the problem. Good. Okay, what is the right answer then? Because there is a air drag force. Yes. Okay. And the net force will be different, acceleration will be different, acceleration of the lead, okay, will be bigger than the other one. That's why that one reaches the ground first. Yes. Okay, 52. A ball thrown upward takes 10 seconds to go up and return to the ground because of air resistance. Again, here is telling that air resistance, the time taken for the ball to go up is more than 5 seconds. Yes. Less than 5 or equal to what? Which one?
I think I would go less than
Why less than?
the resistance is greater than.
Yeah. There is a resistance, yes? Air resistance. So when there was no air resistance, just the force of gravity. Okay? Good? What is the A? Change of velocity over time, yes? Okay. What is the again? Uh, but here in the free fall, yes, when it is just a free fall without air resistance, A is G. Good. When there is a air resistance, okay, A is going to be how much? Less than G. Yes? Less than G. Because there is a drag force. If it is 10, yes, this is going to be, let's say, 8 meter per second. Good? It's not going to be exactly G, okay, because there is a air resistance. It's going to be less than G. Good? Less than G, okay, so what does it mean?
So it's more than 5 seconds.
More than 5 seconds? Why less than?
Because of the force of the air resistance, it's not gonna let it keep going up.
One reason, okay, the force does not let to go up, yes? The force, okay, yes. You know, because drag force increase, at one point the air drag force become equal to the force of gravity, yes? Good? Okay. So one reason is this, okay. The other reason, the acceleration, the net acceleration. Acceleration keep changing. The acceleration is not gonna be always, 10 meter per second squared. Okay, the acceleration is changing. How it's changing? With the velocity. Yes? Good? So because acceleration is changing, okay, it's getting smaller, okay, the time that it takes to go up, okay, is gonna be less than when there was no air resistance. Last time when there was no air resistance, it was 5 seconds. Now the acceleration has changed, it's gonna be less than 5 seconds. Good? A question? Okay, let me just tell you this. Okay, so no air, yes, air means resistance. This ball, okay, you throw upward. When it's in the air, is always empty, yes? Until it stops. But when there is the air, okay, mg, good. What is the drag force direction? In the opposite direction of the motion, yes? We will have a drag force, yes? And these drag force keep increasing, good? Get smaller, sorry, okay, because the velocity is slowing down, okay? There was a drag force, okay, but this drag force get smaller until again become mg, okay, and then come back to the ground, okay? So when it's going up, do you think when this is mg and this is mg plus something, okay? So the net force is different, yes? Acceleration is different. That means that it's take, different time, okay, to get, okay, it's gonna be smaller or bigger. Okay, if this one it takes 5 seconds, when the acceleration, you see, forces are in the same direction, yes? Acceleration is bigger, yes? Here. When the acceleration is bigger, it takes less than 5 seconds to go up, yes? Make sense? Less than 5 seconds, because acceleration is big. Make sense? Okay, again, it's going is just analyzing when it's going upward. Okay, so the net force is going to be bigger. When the net force is bigger, acceleration is bigger. So it takes less because it's they just move the same distance. Okay, let me just explain like this, okay? So let me just explain like a car, okay? So
It's like, okay, when you throw the ball,
it-
there's no air resistance, so it quietens and then it comes down. That's why
yeah, that's why here is telling when it's going up. You read the code. Yeah, that's when it's going up. Yes. Okay. Let me just explain like this. Okay. Let's say you are moving, 10 meter. Yes. Okay. And your acceleration is 1 meter per second. Okay. And it takes, let's say, 2 seconds to get here. Yes. And then is the same 10 meter, but the acceleration is what? 2 meter per second. Do you think the time that it takes to get here is going to be bigger than 2 seconds or less than 2 seconds? Less than 2 seconds because acceleration is bigger. Good. Okay. Now we are done. Okay. We know that bigger acceleration. Okay. Because they are traveling the same distance. Okay. Let's take time to get there. Good. So now solve this problem. Okay. Again, this is no air. Yes. This is with air. Good. Okay.
So when you say no air, you mean no air resistance?
No air resistance. Yes. When there is air, there is air resistance. When there is no air, no air resistance. Yes. Okay. The object, is here at the beginning. Yes. And it has to get, let's say d meter. Okay. I don't know, 100 meter above the ground. Good. In 5 seconds. When there is no air. Good. What is the force of gravity every time? What is the force? What only force is exerted on object is mg. Yes. It takes 5 seconds. What is the acceleration is g. Good. But here mg drag force at the beginning is big. Okay. Sorry, it is in the opposite direction. My bad. Why d is downward? Why d is downward? Because it's moving upward. Yes. The drag force is always in the opposite direction of the motion. Okay. So, but this drag force getting smaller. Okay. Okay. Mg is the same mg. Okay. This drag force getting smaller. Yes. But when you compare, when you compare acceleration here and acceleration here, what is the acceleration here? Acceleration here, mg plus d, yes, divided by m, yes? Net force divided by mass of that object. Okay, acceleration is going to be m divided by m, cancel each other, g plus d over m, yes? If the g was 10 here, it's going to be 10 plus a new number. Let's say it's going to be 12. 12, yes? Okay, you are traveling the same distance, yes? You are traveling the same distance with the bigger acceleration. In same time, bigger time, or less time? Less time. T is going to be less than 5 seconds. Make sense? Because the acceleration is bigger. Okay. Now, how about this one? A feather and coin will have equal acceleration when makes sense, yes? Again, go back to this problem. Where is the why? Drag force is 0. Drag force every time is 0. There is no drag force, yes? It doesn't matter. You fall, it's all true in the air. Acceleration is g, acceleration is g. As long as there is no drag force, okay, so the acceleration is going to be the gravitational acceleration. It's 9.8, and it takes same time. Okay, if you are dropping in the from the same height, it takes same time to reach to the ground. Good. So what is the answer then? Which one is the right answer? Okay, so the ratio of each object weight to its mass is same. The force of gravity is same for each in the vacuum. Their velocity are same. The force of gravity doesn't act in the vacuum. None of the above. Which one is the right answer?
Is it the force of gravity does not act in vacuum?
Okay. Can what did you say?
The force of gravity does not act in a vacuum. So-
No, there is a force of gravity, always. Force of gravity, okay. Good. Hmm? The third one, the velocities are same. You remember what I said here? I said when there is no, yes, the acceleration is same. A is g here, A is g here, yes? Which one is telling this? Which one of these options? Which one of these telling the acceleration is same for both? Just read the first one. The ratio of each object weight, yes? Ratio of each object weight to its mass. Mass cancel each other is going to be G. Weight divided by mass is the gravitational acceleration, yes? When there is no air drag force, the gravitational acceleration for both, the acceleration for both is G. This one is the right answer. This one is, more accurate answer, okay? So we cannot,
Should still be the same on both of them, but
yes,
that's why you said it's more accurate.
yes.
Technically,
The weight is different, yes, okay, because definitely the weight is different, but the ratio of weight over its mass is going to be acceleration. And the acceleration for both is G. 54. So 54, okay, we need to just go a little fast. Okay, we have just 15 minutes, okay, so 54. An archer shoots an arrow. Consider the action force to be exerted by the bowstring against the arrow. The reaction to the force is, okay, this is the definition of the Newton's third law of motion. Action and reaction. So which one do you think is the right answer? Combined weight of the arrow and bowstring, okay, so an air resistance against the bow, arrow pushes against the bowstring, okay, grip of the archer's hand on the bow and friction of the ground, okay, against the third one.
the air is pushing against the both.
Yes. Action and reaction force, yes? Newton's third law. When there are two objects, if object one exerts force on object two exerts exactly the same force but in the opposite direction to object one. This is the definition of the Newton's third law. 55. A baseball player bats a ball with a force of 1000 Newton. The reaction force that the ball exerts against the bat is, again, Newton's third law, yes? Action, reaction, which one? Action, reaction. No, action, reaction. You are exerting force on a ball, the bat. Ball exert force on a ball, the ball exert the same force, opposite direction. If you are exerting 1000 Newton, okay, the ball exert exactly the same. 1,000. They are exerting the same force, okay, but they accelerate different. Okay, accelerate is force divided by mass, yes? They are exerting same force, okay? You know, these force for both are same, but the mass is different. The one has a less mass will accelerate more. Make sense? The mass of the ball is much less than the mass of the bat, yes?
They're talking about when it actually.
Exactly. That moment,
Like, how far,
yes.
talking about that.
Exactly on the moment, okay? You know, bat exert force on the ball, ball exert force exactly on the bat. Same on the opposite direction. Newton's third law. And you may say, oh, why the bat is not moving and the ball is moving? Okay, that's the acceleration. The ball accelerate more than bat, okay, because the mass of the ball is smaller than the mass of the bat. 56. A karate chop delivers a blow of 3,000 Newton to a board that breaks. The force that acts on the hand during this event is 6,000 Newton, 1,500, 3,000 or 0. Three thousand, yes? Action and reaction. Okay, 56, 57. Okay, the attraction of a person's body toward the earth is called weight. The attraction of the reaction to this force is
Is it the person's body pushing against the Earth's surface?
yes, pulling.
Oh, wait, oops.
You know, the earth is pulling you, you are pulling the earth. You know, action reaction. You know, you are pulling the earth is pulling you.
I got it. It is, I got you, all right.
60, it's 58. Truck and a Volkswagen traveling at the same speed have a head-on collision. The vehicle that undergoes the greatest change in velocity will be
Volkswagen,
why?
because it's smaller, so it's probably already going faster
Yeah.
than the next truck.
I don't seem to- Yeah, it's the greatest use.
Yeah, we can explain this with the momentum because you haven't studied the momentum yet. Okay, so, but it's telling that a track and then there would be head-on collision. Okay, and traveling at the same speed and have a head-on collision, the vehicle that undergoes to greater change in velocity will be action and reaction. They are exerting same force on each other. Yes, same force on each other. When they are exerting same force in each other, okay, it means that the mass of the one, acceleration of the one, equal to mass of two, acceleration of the second one, yes?
So because the next truck is bigger. The Volkswagen will change.
Yes. The vehicle that undergoes the greatest change in velocity, okay,
Because it's smaller.
okay, and what is the acceleration velocity multiplied by time, yes? Good. Acceleration is directly related to the velocity, good? So, which one has the greatest change in the velocity? Again, acceleration 1, acceleration 2 is going to be what? Mass of the 2, mass of the 1.
Acceleration's the same, but then the mass is just.
So it's the same type of questions as the baseball.
Yes.
It'd be the same for both, just because we're going on the same speed, but I'm assuming, I mean, the question we're asking, like, what car will have more damage than obviously the Volkswagen? Just because
Yeah, we can talk about that part. Okay, so because that's a momentum, and again, it's gonna be like, okay, you can just compare this with the bat and ball.
Oh, okay.
Okay,
Yeah.
which one accelerate more? The ball. Why?
Small,
Which one accelerate more?
the Volkswagen.
Volkswagen, right? Okay. So, something like that. Okay. The one that accelerate more will have less mass. The one which have a great, because we said that acceleration and velocity are directly related to each other. Yes. Undergoes velocity changes, it means that more acceleration. Okay. Which one accelerate more? The one has a less mass. That's it. That's why, the relation between the acceleration and mass is this. Inversely related. Yes. A1, M1 here. Inversely related to each other. Did you do the mass and acceleration relationship in the class, the Newton's lab, the formal lab?
Oh, we're in the process of doing.
Okay. Acceleration and mass changing inversely. Yes. Okay. The Volkswagen is going to be the right answer. 59. A horse exerts 500 Newton of force on a heavy wagon. The wagon pull back on the horse with an equal force. Action and reaction, yes? The wagon is still accelerate because 59.
So, unbalanced.
If it's moving, it means that there is a if system, if the system accelerate, definitely there is a forces inside. Yes, there are action and reaction, they are canceling each other. Okay, we completely understand that. But if the system is still accelerating, okay, so it means that there is a force inside. Even if we consider, action and reaction, there are other forces that cause the system to accelerate. Okay, so which one is the right answer? This one, yes?
What's starting?
60. During the time of the year when the earth start moving closer to the sun moves toward the earth, but a larger distance move toward the earth, but a smaller distance, okay, so it start moving at the same distance toward to earth and does not move in all in the response to the earth's approach. So this is going to be the last question. Why? Why?
Because they react to each other. One's moving, the other one's moving closer, and that distance shortens.
The distance, yes. Yes. During the time of the year when the earth start moving closer to the sun moves toward to the earth but a smaller distance. Yes. Okay. So we are done with this. Okay. So I don't know. I was planning to do the graph part as well. We are done with the exam prep party almost. Good. Do you like? Do you have a class? What time? 5 o'clock. Okay. Would you like to stay
You're gonna be here.
to do the graph problems? Because the first 44 problem is already recorded. Okay, I can send you the video. Okay, anyone who asks me, I will send the video. I already sent the video to. Okay, so we are done with this problem. Okay, but there are graph problems. Okay, do you like to work on a graph problems now?
Sure, if you're willing to stay.
Yeah, I can stay. Yes, okay. I can stay until okay. We just complete. Okay, so okay. You want to take let's say 5 minute break, 5 or 10 minute break. Okay, I will start. Let me just stop the video. Okay, so we can start the graph. So there are two. This is the first one. Okay, we can start with this one. Okay, you have a graph of velocity versus time. Good. And then you are supposed to find the position versus time. Good. Okay. I need to explain a little bit about this, how the graph is going to look like. Okay, so, and then we go back to this problem. Okay, so, and definitely you have seen these, in your lab. When you were doing the lab, okay, online or in person, you have seen this. Let's say we have a velocity versus time graph, and the motion is the constant velocity. Yes? When it's constant velocity, what does it mean? It means that the velocity is constant with time. 10 meter per second is always 10 meter per second. Negative 10 meter per second. What the negative means? It means that you are moving in the opposite direction, okay, and in the left side of the coordinate system. Good. So that's why it's going to be positive constant or negative constant. Good. So this is positive velocity. This is negative velocity. If I graph the position versus time, okay, position versus time can be this one or this one, yes? Okay. These are for positive, yes? It's linear. Good. Position versus time is linear. Okay. The slope of position versus time is velocity. What is the slope of this line? It's positive value, yes? It's going to be constant value, positive value. Why I put here or here? What does it mean? Here is the origin, yes, 0. Here is behind the origin. Let's say negative something, negative 2 meter behind the origin. Or I can draw like this, yes? Couple of meter away from the origin in the right side of the coordinate system. Let's say this is the coordinate system, yes? 0. If it's 0, you are standing, you are moving your motion from the origin, yes? If it's here, yes, you are standing couple of meter to the right. If this is the one, yes, you are starting your motion couple of meter away. All of this situation is moving to the right. Good. So if the velocity is negative, it can be, let's say, this one, it can be this one, or it can be this one. Yes. Again, the same person. It can be from origin. It can be a couple of meter away from the origin. It can be a couple of meter, behind the origin. Okay, it's moving to the left, but with a constant velocity. It can be one of these, yes, and it depends on where you are standing your motion. Make sense? This is the graph of velocity versus time and position versus time for motion with the constant velocity. Good. We learned other motion as well. Yes. What is the other motion? A constant. V T X T. Again, I assume that at this situation, all start from the origin. Yes. Good. At x equals 0. I don't draw a couple of things. Okay. So, but you can be behind the origin or in front of the origin. Okay, you remember when we had a constant acceleration, okay, constant acceleration means the velocity is changing. Velocity can get bigger, can get smaller. Okay, so there are 4 different situations. Good. What is the velocity value here? Positive, yes? So it means that you are moving to the right. But what happened? What happened to the magnitude of velocity? Let's say this is 10, yes? Couple of seconds later, it is gonna be less than 10. And then at one point becomes 0, yes? Slowing down to the right, yes? When it is slowing down, velocity is positive, but what is the acceleration? Acceleration should be in the opposite direction. When we are speeding up, acceleration and velocity should be in the same direction. When we are slowing down, acceleration, velocity, it should be in the opposite direction. Good? Here we are slowing down, okay? If the velocity is positive, acceleration should be negative. And it makes sense. What is the slope of this line? Negative. So acceleration is negative. Sorry, this is the position versus time. I will draw the acceleration later. Good? Acceleration is negative. So it means that, here is the slowing down, yes? From here to here is the slowing down. I call this motion number 1. From here to here, what happened? I call number 2. What happened to the velocity's value? It was 0, yes? And then keep increasing. Speeding up, but what direction? Backwards, yes. Velocity is negative. So when it's speeding up, velocity and acceleration should be same direction, yes? There you go. Acceleration is negative as well. And it makes sense because the slope of this line is always negative, yes? So number 3. What is the velocity at the beginning? Negative. What happened? The velocity gets smaller, 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 and it stopped. What happened? It's slowing down, yes? The velocity was negative, yes? Acceleration should be positive, yes? Here, the acceleration is positive because the slope of this line is positive. The velocity was 0, yes? Now keep increasing, speeding up. Acceleration positive, velocity should be. So velocity positive means that it's moving to the right side of the coordinate system. Velocity negative, it means that it's moving to the left side of the coordinate system. Yes? You have seen all these graph, okay, in the, during the lab. So I would like to graph position versus time for each one of these, okay? So there are 4 these. I start with this one. Good. So which one of these is represent, is speeding up, velocity is positive, yes? Why velocity is positive? Because the slope of tangent line get bigger. If I just the slope of tangent line. Slope of tangent line. Which one is the steeper? That one. So it means that the velocity getting bigger, the speeding up. Okay. And the slope is positive. So here is acceleration, velocity positive, acceleration is positive. Number what? Number 4, yes? Okay, we call this number 4, yes? Number 4. How about this one? Slowing down? No, the velocity is not slowing down. The velocity is getting steeper, yes? A slope of, there you go. Yeah, the velocity is negative because it is speeding up. Acceleration should be negative as well, yes? Number 2. Good. How about this one? The velocity is getting bigger or smaller? smaller. The magnitude of velocity, you know, the slope of tangent line, yes? The slope of tangent line, you see? Getting small, okay. It's slowing down, okay. The velocity is positive, so acceleration should be, which one it is? Number 1, yes? What is the other one? Again, the velocity gets smaller, okay, but the velocity sign is negative. Acceleration should be positive. Which one is the right one? Number 3. Good. There are, okay, one of these four situation, okay? Then we know how to graph. If we have that velocity versus time graph, it's going to be one of these, yes? If we have this velocity motion, constant motion, yes? We have this graph. If the velocity is constant, the position versus time is linear. If the velocity is changing, yes, the position versus time is going to be the curve or parabola. Make sense? Okay. Yeah, constant is going to be,
Speeding up or slowing down, that's.
is going to be the curve.
way the curve
There you go. You are moving to the right, to the left, okay?
faster, it's gonna be more of
Yes.
a way.
And you can explain again the coordinate system. Yes, okay. You are moving to the right, yes? You are slowing down. Or you are moving to the right, speeding up, yes? You are moving to the left, okay, speeding up or slowing down. 4 different situations. Good? So, now go back to this problem. Okay, the velocity, what happened? The first 5 seconds, yes? The velocity is increasing or decreasing or constant? No. The first, yeah, good. You see, the velocity was 0. Now keep increasing until 100, yes? So the first 5 seconds, let me just,
It's accelerating.
is accelerating to the right or left? To the right, because the velocity is positive. The velocity is, is positive 20, positive 40, is accelerating to the right, is speeding up to the right. What happened from, what happened from, what happened from 5 to 10? Constant velocity is still moving to the right. Yes. What is this one? The velocity is stop. Position doesn't change. The position is going to be the straight line, okay?
Does that mean,
Stop.
I guess I'm not.
Yeah.
Like the 5 and 10 seconds there, is that considered constant velocity?
Yes, constant velocity. The velocity is not changing, okay?
That's considered rest then.
Rest, yes. And then what happened again? Constant velocity. But what is the value of the velocity? 7. Good? Make sense? What, if you were moving,
The straight down lines,
no.
they're just.
Yeah, suddenly some change happened, suddenly, in a very, very, very small time. Okay, just so if I was moving, yes, I was speeding up to the right with I was speeding up for the first 5 seconds, and then my velocity reached to the 100 meter per second. I would move with the same velocity for until 10 seconds, and then I stop, yes, and then I just move exactly in the same direction. Okay, that's it. Good. So, and I would like to find the position versus time. Okay. You remember which one of these graph it was? Yes? Which one it is? Yes? That's the position. Good. So it means that if I want, let me just put this here. Let me just take a screenshot and put it here. Good. If I want to graph a position versus time, yes? Let's say the first 5 seconds, yes? What happened? Curve, yes? What was this? Constant velocity. Okay, it's going to be linear, yes? It will be like that, yes? Until 10 seconds, just linear, yes? This one is curved, this one is linear. What happened here? Stop. Your position doesn't change, yes? Your position is just same position, yeah? Because this is a position versus time. Good? The position is same. And what happened here again?
The flat line.
Another, okay, linear line, okay? With the slope of, positive slope, yes? Positive slope. Positive velocity, positive velocity. Good?
It's ever constant straight like that.
Yeah.
So,
Good? So, but I would like to find the position, okay? I would like to see very exactly, okay? So, how can I do that? Okay, I'm going to show you in the graph. So there is one way, okay, that you need to use the formula. I don't want you to use the formula. Good? I give you a method, okay, to just calculate the how much distance is travel. Good? Area under let's say this is, yes? If you calculate the area, yes, here, it give you displacement. It helps you to find how far it has traveled. You know, what was the formula? You remember? V0 t plus 1 over 2 at squared, yes? You know, you were able to use this formula to find the distance traveled. This is a motion with the constant acceleration, yes? But you don't need to use this formula. If you calculate the area, what is this area? Area of the triangle, yes? What is the area of the triangle? Half base time height, yes? What is the base here? 5, yes? What is the height here? 100. How can I calculate the area? 100 times 5 divided by is going to be how much? 250. Good? Okay, I'll go to the down, okay? So where is the 250 in the in the 0 is what 0, yes? At 5 seconds, it is where, because 200, okay, how many is 1, 2, 3, 4, 5, yes? 200 divided by 5 is 40, yes? It's gonna be somewhere here. Good? 250. What was that? It was curve, yes? I'm not good at. It's gonna be curve, yes? So go back to which one? Sorry, no. Here. I'm gonna use different color. Okay, so I'm gonna calculate this area, yes? What is this area? For the second motion, yes? This is the area of the rectangle. Base time height, okay, or width time length, yes? What is the width? 5. What is the high? 100. 5 times 100 is going to be 500. Okay, You move 250 to the right, yes? Another 500 is gonna be 750, good? Okay, go back down. You just need to go 500 above, yes? Okay, so in the 10, yes, it's gonna be 750. Okay, again, it's gonna be, let's say, 6, 7, 750, almost here, yes? I- Good? What was the line? There you go. Okay, this is 750, good? Okay, so go back here, change the color. What happened here? Nothing. Okay, until 14, you just move, you just have the first, same distance, yes, same position. Okay, so what is the next one? Area for this one, yes? What is the base? 6, yes? What is the height? It is 60. Okay, 1, 2, 3, 4, 5, yes? 20 divided by 5 is 40, yes? So it means that here, so it is 4, sorry. Not 20 divided by 5 is not 40. It's, it is 4. Okay. 76, yes? 76. Okay, 76 times 6 is going to be how much? 76 times 6 is going to be 456. Yes, 456. 456 added to what? 750. Yes, 750 is going to be 1,200. Yes, 1,206. Yes, it's going to be almost here. Almost here. Yes. Which one? 206. Yes. Make sense? That's it. You can watch this video one more time. Okay.
We haven't done, we didn't do anything like this in my class.
But again, it's a practice. Okay, so you are it assumed that you did something similar in the lab. Okay, so that's why. But in the exam, it's not going to be difficult like that. Okay, so
Big thing is just remembering that it's triangle, it's half basement.
half base time high.
Just
Yes, base time. Okay, so ready for the second one? Second one, we have position versus time. Okay, we are supposed to draw velocity versus time. Yes. Okay. But what happened first? Okay, can you explain what happened here? You are speeding, you are standing 20 meters away from the origin, yes, at the beginning. Speeding up to the right, yes, because the velocity positive, acceleration positive, yes? And then moving with the constant velocity, good. To the right. And then constant velocity to the left, yes? Stop, yes? Constant velocity to the right. Make sense? That's it. Okay. Well, how I'm moving. I am speeding up to the right for the first 5 seconds. And then when I reach to that specific velocity, I move with the constant velocity for another 5 seconds. Okay. And then I suddenly change my direction. Okay. Move with the constant velocity to the opposite direction, other direction. Okay. I stop for a couple of seconds. Yes. And then move to the right for last 5 seconds. Yes. Okay. So again, I kind of show you, and then you can do the calculation by yourself. Okay. So, but if I want to graph, how would I graph that? Let me just screenshot. Yes. If I graph that, okay, the velocity versus time, how it's gonna look like? Let's say velocity versus time. Yes. Let's say this is a 5 second. This is 15. This is, let's say 19. Yes. This is how much?
29.
Sorry, 29. Yes. Okay. This is, let's say 1, 2, 3. Yeah, 33. Yes. And then, oh my God, 1 second, 34. Okay, good. So how should I graph that? This is speeding up, yes? Moving with the constant velocity. Okay. And then suddenly the velocity become negative, yes? So how you do that? Okay, go to the negative, yes? There you go, yes? Don't do that. Okay, so you need to show that the velocity is still constant. But you just go down, okay, and then negative velocity. Good. What happened here? Stop. Stop, yes? And then constant velocity, good? Okay,
So go down into the negative.
yes. Make sense? Okay, this is how we can calculate, graph the velocity versus time graph. Okay, but if you want to find the value, the velocity value, okay, so, again, you can just find the velocity value. I just show you how to find the velocity value, okay? Let me just, okay, draw. What is the displacement here? 22, 100, 1, 2, 3, 4, 5. Yes, okay. It means that each one is 4 unit. Yes. Here is 104. Yes. What is the displacement? 104 minus 20. Good. Okay. 104 minus 20. Can you check? 81. Oh, 108. My bad. Yes, yes. 108. Yes. 108. Yes. Minus 20. Yes. It is 88. So displacement is 88. You remember, I would like to calculate the acceleration. D was 1 over 2 AT squared, yes? What is the displacement? 88. 1 over 2 acceleration. What is the time? 5 seconds, yes? 5 power of 2, yes? Okay, go ahead and calculate this. Okay, 2 times 88 divided by 25. This is going to be your acceleration. So acceleration will be One. 176 divided by 25, yes? It's gonna be 7.0. Good. Okay, how can I find the velocity then? The velocity formula was what? V time A time T, yes? What was the acceleration? 7.04. Good. What is the time? How many seconds? 5 seconds. Okay, multiply this by 5. What would be the velocity? 35.2, yes? I don't know, okay, how, let's say, it doesn't show. Let's say this is 10, yes? This is 20. This is 30, yes? This is 40. 35 is going to be middle, yes? The first 5 seconds. Which one? And then you still move with the same velocity, yes? Same velocity, yes? Constant velocity. Good. For how many seconds? 15. Good. Okay. So, and then, but again, you know, you would be able to find the slope, you know. You didn't need to calculate the acceleration and then, okay. Because if you find the slope here, good, it's going to be the velocity, yes? The velocity is change of position over time, yes? Change of position, yes? How much is changed? Over time. And then you can calculate this over time, yes? Displacement over time, yes? Here is 0 and then displacement over time. Good? And then, but we calculated the velocity here. Whatever the velocity got here, okay, is going to be the velocity here, okay? Because the final velocity here, makes sense?
Yeah.
Okay, it's going to be okay. But you would be able to just find the slope of this line, okay? Let's say we just found it, okay? And then find the slope of that line, yes? Run, rise over run, rise over run. Okay, here is going to be negative, yes? It's going to be somewhere here, yes? I don't calculate it, okay? So, and then the other one is going to stop, yes? And then this one is going to be rise over run, yes? And then you can calculate the value. Make sense? Okay. We are done. Okay. Let me just stop. Okay.